We previously talked about using virtual machines or VMs for testing. Now we're going to go through using VMs for creating separate security domains, enforcing isolation and compartmentalization with them. VMs are a kind of sandbox and are an excellent tool for implementing isolation and compartmentalization to reduce risk, impact, and to control an attacker. They are also a great tool for establishing isolation and compartmentalization for aliases, as discussed in the section on OPSEC. You must have some sort of isolation and compartmentalization for aliases, whether that be virtual through a virtual machine or physical. Virtualization provides security because it reduces the interfaces between the security domains while allowing security domains to exist and communicate through those interfaces. Security domains that just exist in isolation have limited use as they have nothing that they can communicate with. They do have their purpose, but it's a limited use case. So we use virtualization because it reduces those interfaces between the security domains while still allowing the domains to exist and communicate through those interfaces. Hopefully you set up the test environment. I've been going through the course and testing various things out, so you should now be familiar with VMware and/or VirtualBox. These are the Type 2 hosted hypervisors. The hypervisor is installed on the operating system that you have. The main Type 2 hosted hypervisors are VirtualBox, as we've mentioned. There's the VMware Player and the Workstation. VMware also has something called VMware Fusion, which is for Mac. There's something called Parallels Desktop, which is for Mac. There's also Vagrant, VPC, and Citrix Desktop Player, which is for Windows and Mac. I recommend VirtualBox for security, privacy, and anonymity as it's free, so there is no money trail if non-attribution is important to you. Also, VirtualBox has snapshots. VMware doesn't have snapshots on the free version. Snapshots are a useful security feature to return back to a known good state. Snapshots enable you to make a permanent backup of the entire virtual machine and then restore back to that virtual machine. So it's a useful feature for security to return back to a known good state, as I said. So that's the Type 2 hypervisors, which you should be reasonably familiar with your use of VirtualBox or VMware. Now there's the Type 1 native hypervisors, also called bare metal hypervisors. There is no host operating system. In fact, the hypervisor is really the host operating system. Common Type 1 native bare metal hypervisors include VMware ESX and ESXi. There's also Oracle VM Server. Microsoft's got its Hyper-V product. And there's also the free and open source Zen server. Type 1 hypervisors have the advantage of being faster and probably more secure as there is a reduced attack surface. There's no operating system that they're sat on that can be attacked. You might set up a Type 1 hypervisor on a server on your network or remotely in the cloud to escape an adversary's sphere of influence that hosts virtual machines for you. I like and use Zen server, which is free. I have a Zen server on my local network which hosts many of my virtual machines. And you can install Zen server just like any other operating system. You can even install Zen server in a VirtualBox if you want to play around with it and see how it works. Simply download the ISO and install it like any other operating system. And that's what the interface looks like. It's very similar to VirtualBox and VMware, it's just dedicated on its own server. Other than Type 1 and Type 2, there are also hybrid hypervisors that effectively convert the host operating system to a Type 1 hypervisor. That might also be of interest to you because you can use it for security, for isolation and compartmentalization. First is KVM or Kernel Virtual Machine. It's an open source FOSS GPL licensed hypervisor that comes with GNU Linux OS. And other than VirtualBox and Zen, I can also recommend this as a virtual machine for Linux. But do make sure you use it with Virtual Machine Manager, which is a front-end GUI for KVM, making it simpler and easier to use. And that looks like this, and as you can see, it's pretty similar to VMware and VirtualBox. And then when you want to see the settings for the virtual machines, again, it's pretty similar to VMware and VirtualBox. You can see all your various options for setting up the virtual machine. If you're considering using KVM, here's a guide for Debbie and Jesse. You can see it's not too difficult. The packages are available in the repository. Simply install them and give it a try. It works with Unix, which is a security-based operating system we're going to talk about shortly. So if you want to use Unix, you might well be using it with KVM if you're using Linux. But as I said, we'll discuss that shortly. There are quite a few Linux VMs. KVM probably is the main one, as it does come with GNU Linux OS. But a couple of others worth a mention is OpenVZ, which is a container-based virtualization, and also Linux Containers, which, as the name suggests, is another container-based virtualization application. FreeBSD uses a mechanism they call jails, which are independent environments implemented via operating system level virtualization, wherein each jail is a virtual environment with its own files, processors, and user accounts, and bound to a different IP address. And each jail is completely sealed off from the other. If you use FreeBSD, you will be aware of it already, I'm sure. This works very effectively as an isolation and compartmentalization security control. Anyone familiar with Oracle Solaris will know that there's a similar concept which they refer to as zones. I've worked with those at some banks, but Solaris is not a very used operating system at the moment. Finally, there is Docker, which is quite the buzzword at the moment. To explain what Docker is, let me show you this diagram. If you think about VM hypervisors such as Hyper-V, KVM, and Xen, they're all based on emulating virtual hardware. That means they're heavy relatively in terms of system resources. Docker containers, however, use shared operating systems. That means they are much more efficient than hypervisors in system resource terms. Instead of virtualizing hardware, containers rest on top of a single Linux instance, meaning you have a small capsule containing your applications. Docker is becoming very popular for businesses because of this. It enables virtualization with lower system requirements. So Docker is another option for isolation, but it is mostly implemented server-side. Solaris Zones works very similar to this. You can also get what is called a virtual appliance. Here are examples from Turnkey Linux, a service I use and highly recommend. They integrate with Amazon Web Services and you can deploy virtual servers in literally seconds. So let me give you an example. Maybe you want to run a VPN server or an OpenVPN server in the cloud via Amazon Web Services. With the pre-configured virtual application, the time and skill to do it is vastly reduced. You're able to select the virtual appliance that you want to use, in this case OpenVPN, and quickly and easily deploy a full virtual server with operating system and OpenVPN within minutes based on this virtual appliance's configuration. Or maybe you want a domain controller to authenticate local network users. You can take this and install it on VirtualBox or a dedicated Xen server, and you've got a local domain controller that's already set up and configured. You will obviously need to configure it a little bit for your environment, but it's there pre-made. You do, of course, have to trust Turnkey that they have not backdoored it in some way, but in the same light, we have to trust all operating systems and applications as well as virtual appliances. We'll talk more on Turnkey Linux later and in other sections. This is Wikipedia's page comparing all the platform virtualization software, and there is loads of them, as you can see here. So that's a useful link to see what's out there. What I've covered is what I see as the best, but there are many, many alternatives. Moving away from dedicated virtual machines, it's inevitable that operating systems will move to using virtualization as part of its core security. Windows 10 has made that move already. Windows 10 Device Guard uses hardware technology and virtualization to isolate the decision-making functions from the rest of the operating system, which helps provide protection from attackers or malware that have managed to gain admin rights. Type 1 hypervisor technology that is used to run virtual machines in Microsoft Hyper-V is used to isolate core Windows services into a virtualization-based protected container. These hardware-protected containers are guarded by the IOMMU and other mechanisms within the CPU. So you can see that Windows 10 has taken quite a leap into security through isolation and compartmentalization by implementing this Windows 10 Device Guard. This will make Windows 10 harder to compromise. And I talk more on Device Guard in its own section, but it's obviously worth mentioning in the section on virtual machines, as that is where operating systems' core security functionality, I believe, is moving towards.